There we go. Okay, so we missed the first example in the recording, but hey, someone actually, not in this class, in another class, actually has been watching the videos and commented on YouTube, said, hey, thanks for posting this video, you're a lifesaver. And it was not a random person I didn't know, it was actually a student here. So, remember, these videos I post on my website. No, it's free, MsGraceMath.weebly.com, in case you're absent, or you know that you have your test coming up on Tuesday. Have you? Good. Good. I hope you use them. Otherwise, it's just wasting my time. Styles? You can hear my voice because I have a mic. You can kind of hear yours sometimes. You guys are silly. Okay. Just like our lesson last time on multiplying and dividing, I always asked you to insert what first? Parentheses. Where do we have binomials? Same thing here, especially the numerator. I mean, you can put it on the denominator, I guess, if you want. There's a reason, because this one has a trick. Number 3 on your homework has this trick. If you're not paying close attention, you'll go too fast and you'll get it wrong. First of all, do we have common denominators? Yes. Good. We do. So we can take the 2 fractions and morph them into 1 fraction. With the common denominator, the denominator won't change. Okay? Even though it looked awful, it's not a big deal because it won't change. Now, I'm just going to, for right now, some of you can do this in your head, but I'm just going to copy it straight down the way it's written. 5a plus 8 in parentheses. Then what comes next? What's the operation? Minus. That's important. 6a minus 4. It's also why we had to put these parentheses in. Because right here, there's a secret number. What number's in front of the 6a? -1. Okay? Both of these pieces are being subtracted. Most people will go like this because you're going too fast and you're not thinking straight. And you go, oh, okay, I'm going to subtract the 6a, and then I'm going to put -4. What's wrong with that? Right, it's +4. Both pieces are being subtracted. The -6a is being subtracted, and we're subtracting a -4. What happens when you have to subtract a negative? Subtract a negative. Changes to positive. I call that wiggle, squiggle. Wiggle, squiggle. Subtracting a negative changes to a positive, plus. The denominator, again, is the same. Okay? Chips? When it's common. When it's already common, yes. Okay, what do we do now? Think about adding fractions. What do you think we do? How do you get -1a out of this? What are you doing? There it is. Combine like terms. We have 5a minus 6a is how many? -1a. Now you can write the -1, but you can also write just -a. That's the same. And then we have 8 plus 4, which is a positive 12. Okay, one thing you need to do on your homework, because when we read off the answers, they will be in standard form. Remember, standard form means highest exponent to lowest exponent. So here we have a to the first power, and then the 12 is a to the 0 power. So it's descending power. Okay, those two both had common denominators from the beginning. Are there any questions about when we have common denominator at the beginning? Remember, number 3 on your homework is just like this one, example 2, except for it doesn't have the fun denominator we made up. But it does have that subtract in the middle, which means you have to distribute a -1 into the second binomial. So be very careful on number 3. Okay, let's try one without a common denominator. Example 3. 3 over 7y to the 4th. 3 over 7y to the 4th times, oh, not times, sorry, plus, thanks for catching that, 2 over 3y squared. Okay, I want you to turn to your neighbor and discuss how could we did a couple practice problems on the board with regular fractions, remember, of how to come up with a common denominator. I want you to turn to your neighbor and talk about how can we make 7y to the 4th and 3y squared the same denominator, common denominators. Turn to your neighbor and discuss. Come up with some ideas. What can we do? Talk to each other about how we can make those common denominators. Similar to what we did over there on the board with 1/3 plus 1/2. Oops. Okay, about 10 more seconds. Three, 2, bring the conversations back, please. 1. Okay, who thinks they figured it out? Allison? Okay, so what do you want the coefficients to turn into? Instead of 7 and 3, you want them to be 21. So like we did, we times top and bottom by the number required to make it 21, right? So what does 70 times by? 3. Top and bottom, so it's actually multiplying by a fancy form of 1. Because 3 divided by 3 is 1, and so that doesn't change the problem, which is why it's allowed. Okay, over here, we need to times top and bottom by what to make 321? 7. Okay? So far we have the coefficients to match now. But the y's don't match. This one has 4 and this one has 2. So now what? You could make them 6, but it wouldn't be simplified. Haley? Okay, great. Because this one already has 4, right? This one has 2. How many more does this need to match y to the 4th? 2. So we times by y squared. Top and bottom, though. You don't want to make it 6, or you'll just have to simplify at the end. Okay, because at the end our answers need to be simplified. All right, let's go through and figure out what we've done here. Now the denominator is 3 times 7 is 21, and how many y's do we have now? Y to the 4th. Now we're going to morph both fractions into one fraction since they have a common denominator. Over here we have 3 times 3, which is 9, and then it says plus. Make sure you're paying attention to the operation. And right here, what do we get? Great. Okay, you do have to check. Is there anything that we could simplify by? Do they all have y's that we could divide? Okay, what about 9, 14, and 21? Are they all divisible by, like, 3? No. Okay, so this is almost the answer except for standard form. The numerator should be flipped to y squared plus 9 over 21y to the 4th. Okay? So, because we'll read our answers, I'll be reading them in standard form. Okay, so make sure your final answers are in descending power, highest exponent to lowest exponent. Any questions on number 3, finding a common denominator? Okay, this was one with a monomial in the denominator. Now we're going to do a binomial in the denominator, still find the common denominator. Example 4. Let's see. C over 3c minus 1 minus 4 over c minus 2. C divided by 3c minus 1 over 4 divided by c minus 2. What's the first thing we should do on these problems? Multiplying, dividing, adding, subtracting. Parentheses. Find the binomials and put parentheses. That way you know what's actually being subtracted. And then, because we can only cancel if neighbors are being multiplied. And so that's good to know where the groupings are. Do we have a common denominator? No. So how could we make them match? Just like how did we make 1/3 plus 1/2 have a denominator of 6? How can we make these match? Ariana? Yes, you have to multiply both. Yeah. Okay, she was saying this guy has a 3c. Can we just times the c only by 3 so at least match? But if you times by 3, it'd have to be times to both. That's a good question. Okay, so basically, in here, original denominators were 3 and 2, right? Didn't we just multiply the denominators together? We're going to do the same thing here. Okay, so 3c minus 1 is going to be multiplied by what? C minus 2. But if we multiply it on the bottom, we have to multiply it on the top. C minus 2 divided by C minus 2. And over here, we're going to times by what? 3c minus 1 and 3c minus 1 on top and bottom. Now do their denominators match? Yep, they have the same factors. So now we can morph them into one big fraction with c minus 2 times 3c minus 1. Any questions how we got the common denominator to be c minus 2 times 3c minus 1? Yeah? Mm-hmm. Yep. Sometimes it's not always the simplest form by just multiplying the denominators together, so at the end you just have to make sure it's simplified. But yeah. Okay, so we're going to just write what we have starting on the left. We have c minus 2 times c. Some of you will be good enough that you can skip this middle step, but for right now we're going to write it. What's the operation? Subtract, and then 4 times 3c minus 1. Now what do we do? We can't cancel out because this guy's being subtracted to that guy. It has to have pure multiplication across. That's a good question. Same with this one, because of that subtraction symbol, we can't subtract c minus, just cancel off c minus 2. Can't we distribute? Yeah, that c is being times to the parentheses, so we can distribute it in, which becomes c squared minus 2c. Is there anywhere else that we need to distribute? I'm glad you said it was negative. Negative 4 needs to be distributed in. Selena, what's negative 4 times 3c minus 1? Negative 4 times 3c. Okay. And then negative 4 times negative 1. Good, positive 4. Okay, all over the same common denominator which we found, which is c minus 2 times 3c minus 1. Aiden, what would we do now? What did we do as the last step on the problem before? Well, that one's not a great example. Maybe example 2. Here it is. Okay, we distributed the negative 1 in, and then what did we do with the numerator? Added what? The like terms. Good, that's what we need to do here. We have like terms, right? What are the like terms? Negative 2c and negative 12c, which makes negative 14c. Okay? Before we put the denominator in, we should just double check. Does this numerator factor so that we have a cancellation with one of the factors in the denominator? Can you think of two numbers that multiply to 4 and add to negative 14? What multiplies to 4? 2 times 2. Are those ever going to add to 14? No. Okay, what about 4 times 1? Is that ever going to add to 14? Okay, so the factors don't come out nicely. They're not integers that multiply to 4 and add to negative 14. But that's something you need to check, because if we have factors in the denominator, you have to make sure the numerator doesn't cancel one of them out. So our very last step is just do a double distribution in the denominator, and we're done. Okay? Who can tell me what the denominator becomes? Okay, 3c squared. It's not just plus 2. There should be 4 terms. Okay, so c times 3c is 3c squared. C times negative 1 is negative 1c. Negative 2 times 3c is negative 6c. And negative 2 times negative 1 is positive 2. But we have like terms in the middle. What do those two become? 7c. So I'm going to be lazy and just erase it. But, oops. Negative 7c. And that was our squared. There we go. Okay, we're going to do one more just to solidify it, and then we'll work on our homework, and we can do a few together if you get stuck later on. Okay? Any questions on this problem before we go on to the last one? Okay, it does get a little more complex when we have to find a common denominator. It's nice and easy when it starts with common denominators. So last example. 9 over m plus 2 plus 8 over m minus 7. 9 divided by m plus 2 plus 8 divided by m minus 7. Alright, once you have that written down, I'd like you to turn to your neighbor and discuss how could you get those denominators to be common. Turn to your neighbor and discuss how can we get those denominators to be common. Thanks for talking to your neighbor. How can we get those denominators to be common? Good, I like all the teaching I hear. People are actually teaching. Alright, so I'm going to put parentheses around my binomials, and then you can tell me what you learned from your neighbor. M?
We think we're talking about this, but what do you, like, I don't know. I think I know this.
Okay, who can explain it? Harbor? Just negative 7? And minus 7. We need the whole binomial. Times the two denominators together, right? And notice I put parentheses so that the whole quantity is they're both being times to 9. Okay. Then, Austin, what else do we do over here? Not just 2. No. They have to match. M plus 2. There we go. Okay. So now we have a common denominator, so we can morph them into one big fraction, which has our common denominator m minus 7 times m plus 2. I'm just going to copy the numerator as is right now, so I can morph into one fraction. We have m minus 7 times 9 plus 8 times m plus 2. Any questions there? Okay, Lisa, what would we do now? Good. Does the 9 get distributed to m plus 2? No. Good. So this 9 only goes to those 2, and then we'll do the same with the 8, right? That goes to those 2. Okay, so Louisa, when we distribute the 9 in, what do we get? Good. And then when we distribute the 8 in, what do we get, Silver? Okay, and we have, for the time being, we're just going to leave them as the factors. Okay. Heather, what do we do now? Like terms on the numerator, right? Okay, so Heather, what would we get for the numerator when we combine like terms? Nine m plus the 8m. 17 what? Good, and then our constants are negative 63 plus 16. That's a hard, good, that's a hard one because of the negative. Okay. Is there anything that would factor on the numerator so that we'd have a match to cancel in the denominator? No, there is one on your homework that does. So I'm keep going over this because be aware. Check, make sure none of the factors cancel. So we multiply those back together. We get m squared minus 5m minus 14. Make sure when you're multiplying a binomial times a binomial, 99% of the time you get a trinomial. The only time you don't get a trinomial is when you have difference of square or like something like this. Okay, where it's the same except for a different operation. Because I'm seeing some people who have said this was m squared minus 14, and you're forgetting the middle term. So please realize it's going to be a all right. Stop this.